Hello everyone, welcome back to another video, and today we're going to be talking about the risk for some fairly active and strong thunderstorms across mainly southern England through the afternoon and into the evening. Just by getting an overview of what areas are at risk, I'll show you my convective outlook, which I put on my website about 20 minutes ago now, and you can see we have a level 3 out of 5 which is extending from South Wales along the south coast and then into parts of eastern England, and then the main area is the level 4 out of 5 which is mainly across eastern England and then kind of going from the south coast up into parts of East Anglia as well. And that's where the main risk of thunderstorms is expected to be during the afternoon and especially into the evening. We also have a couple of severe areas across kind of parts of southwest England into Wales and also eastern England, and these are where the storms have the possibility, it's not guaranteed, but they have the potential to be severe thunderstorms with flooding and maybe some hail around 2 to 3 centimeters in size. So we'll start off by getting an overview, and to do this I'll show you this chart here, which is the 500 millibar vorticity chart from the European model. And this may sound kind of really, it may sound and look kind of complicated and confusing, but really once you kind of understand it, it's not too bad. Vorticity is the kind of fancy name for kind of spinning of a fluid, and in this case the fluid is the atmosphere, so it's kind of just like the spin and the rotation in the atmosphere. And then 500 millibars is a way of kind of looking at height, because when you're at the surface the pressure is kind of pushing down on you from the atmosphere, and that's usually around 1000 millibars. And so when you go up kind of into the atmosphere, naturally the pressure is decreasing, and so if you look at, let's say, kind of 500 millibars in this case, that's kind of a way of going up in the atmosphere, and usually this level is around 6 kilometers up into the air, so it's kind of halfway through, and it's quite a good kind of height to look at the kind of general pattern of the weather. And so now that that explanation is out of the way, you can see here we have a low pressure system. That's kind of where these kind of circles are kind of coming together, and that's just to the west of Spain and Portugal. And then you can see we have kind of the flow coming like this from that area into the UK, and that's bringing kind of warm, moist and unstable air. And when we've got the lift for storms, which I'll talk about in a second, and mixing with that unstable air, you often get thunderstorms. But if I move this kind of loop through, you can see that we have a lot of kind of colours moving into the UK during the course of the evening, and those kind of colours and different kind of bumps in these lines are kind of the areas of lift and our kind of upper level disturbances, which will be the triggers for storms. And you can see we have two main areas to look out for on this map. One of them is this kind of small band of colouring and this slight bump in these lines that you can see here, which is moving into southern England, and that is for 12 o'clock, so in about 10 minutes. And this area of kind of upper level forcing is responsible for this area of showery, not showery, this area of thundery rain, which is currently moving from the Channel into kind of southern England. And if I play that through, you can see we have those bright colours indicating thunderstorms with lightning and possibly the risk of some flooding across parts of the southwest. As you can see, quite a lot of heavy precipitation been building up over this area. So this area of lift correlates quite nicely with this current area of storms here, and as this band moves northwards, we're expecting it to continue to weaken but still bring the risk of some kind of isolated lightning strikes in this general region. Kind of in this orange zone, we'll have the risk of some lightning strikes, but the reason this is weakening is because, as you'll see on this loop, this area of forcing kind of becomes a bit more kind of dilute, as you can see there, kind of vanishes a bit, and also the atmosphere is quite saturated, it's quite moist, and that really reduces the kind of lightning potential with these areas of forcing, and can really can really turn them into just normal heavy rainfall which does not have lightning in it. So that's the area of forcing that I just talked about. The second one is the more significant one, and you can see it originates from this morning all the way from kind of Spain and Portugal. And I want you to watch, actually let me change the colour on this pen because it's not very easy to see, but I want you to watch what happens to this kind of strip of bright purple colours as it moves through. It kind of really rapidly transforms northwards. This is by 6 o'clock, you can see it's now over France, and then by kind of sorry, I just skipped through there, but by kind of 9 By 9 o'clock it's moving further north, and then you can see by kind of midnight it's turned into a proper kind of shortwave trough, which moves then into southern England. And you can clearly see there we have those colours, we have that kind of bend in the lines, and it's a proper kind of upper level disturbance with a fair amount of lift, which is really going to help trigger those storms. So we do have the upper level support for storms, that is pretty clear. And just to show you something, it's always good to compare the models and what they're showing or forecasting to the observations. And you can clearly see this is the water vapor imagery, by the way, so the kind of green blue colours are a more kind of moist air, and then the warm kind of yellow red colours are dry air. You can see here quite nicely where we've got that upper level low, because you can see it's spinning like that. And then also note where this kind of band of dry air is. You can see that quite clearly. That is correlating to our area of vorticity or spin right here, which is eventually going to turn into our lift for storms in the evening. And you can see that correlates quite nicely, so this model is on track. So pretty much we've got the perfect amount of kind of upper level support for fairly significant thunderstorms in this general area during the evening because of this kind of area of energy. So now that we've looked at the upper levels, we can show you a bit more kind of closer to the surface. And to do this, I'm going to use the row model here, and I'll show you the CAPE chart. And CAPE, I talk about it quite a lot in these storm forecast videos. That is the convectively available potential energy. So pretty much the energy that storms have. And you can see during today we have kind of low CAPE. That's one reason why these storms aren't expected to be that active. It's more just going to be thundery rain as they move north. But what you do notice is that we have a lot of instability just to the south of us. You can kind of see those yellow-orange colours moving in from France. And then what happens during the evening is that this is at 10 o'clock, and you can see we have those kind of dark green and yellows and oranges across this area of kind of eastern England. And that, combined with our up level trough, is really going to get those storms going, because you've got the lift, the air is rising, the air is kind of filling in from the surface to replace that, and what happens is you get those clouds forming, those storms forming, and when you've got all this energy here, eventually those storms can become quite active. And if we show you what the radar does look like on this particular scenario, you can see we start off with kind of showery rain across the kind of western areas and northern areas of the UK associated with this band once it weakens and moves north. But then notice that you've got these kind of dots starting to appear, and that is because we've got the energy from this moving through. And if I just play it forward, you can clearly see that grows upscale, or kind of grows larger, into a quite potent area of thunderstorms, and likely severe thunderstorms in this region here. And I mean, I wonder if this would bring the risk of some strong wind gusts, but I mean mainly it would be lightning, hail, and just very heavy rain. But you can clearly see what could happen there is we get those storms forming and then they move north. To show you another high resolution model run, we can use the UKV. This is the Met Office high resolution model. I also think this has a fairly good handle of what's going to happen here. If I play this through, you can see that band of rain weakens and moves north kind of across Wales and into parts of England by the afternoon and evening. And then notice what happens again is that we get those kind of showers and storms starting to appear, and then when we get that big upper shortwave moving through, they really explode into life across this region. Those purple colours showing where they've got properly heavy precipitation, and then that moves into a fairly organised cluster out across parts of eastern England by the early morning, kind of 1 2 a.m. And that's the main reason for having this kind of red zone level 4 there, because with this much upper level energy and with that instability combined, it just does not make sense for there to be kind of not storms firing in this region. And a few models, I mean, for example, I'll show you the German icon model here. A few models were not really showing this risk as much across parts of kind of the south and southeast. For example, you can see here that was kind of much more further east. And especially if I show you, for example, older runs, so this was the Roman, the midnight French model, you can see it was showing, I mean, mainly just thundery rain there. And if I go back even further, you can see the threat was much further east. But really, given the upper level support, given the instability, it does not really make sense for there not to be storms. And that's why I'm definitely leaning towards the UKV solution, with kind of strong thunderstorms moving through parts of the London area, Kent, Essex, and then into East Anglia during the evening, bringing the risk of heavy rain, lightning, and possibly hail. To get an idea of just how severe the storms might be, this will probably be kind of just finishing off here. I can show you some forecast soundings, and these are quite good. I think I've talked about them a bit before, but these are quite good for getting kind of an idea, like a 3D look of the atmosphere. And you can see here, this is quite an impressive sounding for elevated thunderstorms. Let me change the color to a white so you can see more clearly. You can see we have a stable layer at the surface, so these storms are going to be elevated. That means the inflow is coming from a layer above the ground, not from the surface. But you can see we have a fairly significant amount of elevated instability there. That's the difference between the white dashed line and the red line. And also, if you kind of ignore the lower half of the sounding, because it's going to be elevated, so if you ignore that, you can see we have fairly supportive wind profiles for severe storms. I mean, actually, to be fair, on this particular one, there is not much mid-level shear, but still there is just about enough shear that some storms, if they do form, they could potentially be severe. But just to summarise, we have the risk of some strong to severe thunderstorms across eastern England during the evening. And thanks so much for watching, everyone. Bye bye.